Hello viewers, this is Wagda Ronald taking you through this tutorial on O-level physics, and this tutorial are going to talk about the topic of on magnetism, but the subtopic will be force on a current carrying conductor. This topic is usually studied in senior 4 term 1, so if you're in senior 4, this topic is best for you. So these are the very questions I left in the previous video, and I believe by now you've already tried them out and ready to check your progress. So we shall start with question 1, and the source of question 1 is UNEB 2008 paper 1 question 43. So part A says, state one factor which affects the magnitude of the force on a current carrying conductor in a magnetic field. So one of the factors is the current in the conductor. Another one is the strength of the magnetic field, and also the length of the conductor in the field determines the magnitude of the force. So basically any one of the three, you'll be able to get yourself the 1 mark. So now we shall go to part B. Part B says that figure 4 shows a wire in a uniform magnetic field. If the force acting on the wire is into the paper, Roman 1 indicate on the diagram the direction of the current through the wire. So remember they told us the force is into the paper, so we shall use Fleming's left-hand rule. So Fleming's left-hand rule, if the force is into the paper, it will be downwards. As you can see, this thumb denotes the direction of the force. Then they also, the field is in this direction to the right, so this one will denote the direction of the field to the right. So when you do that, you realize that the second finger, which denotes the direction of the current, is going the other side, meaning the current is flowing from B to A. Therefore we shall come on our diagram and locate our arrow B to A. So that will be the direction of the current. Now Roman 2 they said, explain what happens when the battery terminals connected to wire AB are reversed. So when the battery terminals connected to wire AB are reversed, the direction of the current reverses. Therefore, by Fleming's left-hand rule, when this direction reverses and the field remains in the same direction to the right, you realize the thumb will be pointing upwards, meaning the force will be in the upward direction. Therefore we shall come and say that by Fleming's left-hand rule, the force acting on the wire is now out of the paper, so the wire jerks upwards. Remember, the force is now upwards, so that's why it jerks upwards. So basically that's what they wanted, and let's see how marks can be awarded. So the first paragraph will be 1 mark and the second paragraph will be another mark. So that's how we could get the 2 marks. Now for Roman 1, when you go back to Roman 1, for this arrow you realize that you shall give yourself half a mark, full mark for the arrow, and that's how you can get the 1 mark which was shown. So now we shall go to question 2. Question 2 came from UNEB 2002 paper 1 question 49, and part A says, what is a neutral point in a magnetic field? So we shall come and say that a neutral point is a point in a magnetic field where the resultant magnetic field strength is 0, and when you write that you get yourself 1 mark. Now part B says that the diagram in the figure shows a straight conductor carrying current vertically upwards placed near a bar magnet. Sketch the magnetic field pattern around the wire and magnet. So first of all, if the current is upwards, it means it is out of the paper. Therefore it will be in an anti-clockwise direction. The direction of the field will be in an anti-clockwise direction. So we shall come and draw our direction of the field in an anti-clockwise direction. Now when you come to the magnet, remember field lines of the bar magnet run from north to south, so we shall do that above and also below. So basically that's what they wanted, and now let's see how much can be awarded. So the field for the wire current conductor is 1 mark, and for the bar magnet there are 2 marks, which give you 3 marks. So now we shall go to question 3. Question 3 comes from UNEB 1992, paper 1, question 10, and this is the figure. So they say an aluminium foil carrying a current is placed in a magnetic field as shown above. Part A, which when switch K is closed momentarily, a force acts on the foil. State. Roman 1, the direction of the force. So first of all, you realize that when switch is closed, when you close the switch, it means that current moves from the positive terminal to the negative terminal, so it will move in this direction like that. Therefore, through the aluminum foil, current is in that direction. Therefore, when we use Fleming's left-hand rule, we shall come and get this. Remember, current direction of the current is this direction, the field is in this direction because it has field lines run from north to south. Therefore, when you do that, when you're using your left hand, you realize that the thumb will point upwards, and because it points upwards, you shall come and say that the direction of the force is upwards, or you can say out of the paper. And when you do that, you'll get yourself 1 mark. Now part 2 says that they want you to state 2 factors which affect the magnitude of the force. So one of the factors will be the current in the conductor, strength of the magnetic field, and length of the conductor in the field. So any 2, you get yourself the 2 marks. So now shall go to Roman 3. Roman 3 says, what happens to the force when the foil is slowly turned until its ends point exactly in north-south of the magnetic field? So when it points north-south, it implies that the angle between the field and the force will be, the angle between the field and the current will be 0. Therefore, the force will become 0. So we shall come and say that when that happens, the force goes on reducing until it is 0. Remember, angles have to be 90. Angle between the current and the field has to be 90. Angle between the current and the force has to be 90. Now, when the angle is 0, it means that the force will also reduce to 0. Now shall go to part B. Part B says that name 1 device which works on the principle illustrated in the above diagram. So the device which works on the principle illustrated in the above diagram, that will be, first of all, that is 1 mark for Roman 3, and this will have a moving coil galvanometer and a DC motor. So any one of the 2, you'll get yourself your 1 mark. So that has been question 3. Now let's go to question 4. So question 4 came from UNEB 2005, paper 1, question 46, and part A says, what is a soft magnetic material? We shall come and say that a soft magnetic material is a material which is easy to magnetize and also to demagnetize. So when you write that, that will be 1 mark. Now part B says that state 2 ways in which a bar magnet can be demagnetized. So one way will be by heating the magnet to redness, another one will be by placing the magnet in a solenoid connected to a conductor. So other ways could be 1 by hammering, dropping, hitting the magnet while lying in the east-west direction, or by withdrawing the magnet in the east-west direction while current is flowing. Another one can be poor storage of the magnet. So any you'll get yourself the one, any two will get yourself the 1 mark. Now we shall go to part C. Part C says that figure 9 shows a straight conductor carrying current between the poles of a permanent magnet. Sketch on the diagram above the resultant magnetic field pattern. So that will be the magnetic field pattern, and half a mark will be for that this field, another half a mark for above, another half a mark for the field below, another half a mark for the field on the south pole. So that's how the 2 marks could be got. Now we shall go to question 5. Question 5 came from 1994 of UNEB, paper 1, question 6, and part A says sketch the magnetic field pattern around a straight conductor carrying a current in the plane of the papers. Know that word, in the plane of the paper. So you already know that when current is into the plane of the paper, using the right hand grip rule, it will be in that form, and therefore when you look from above, the direction of the field will be in a clockwise direction. Therefore you shall come and say, first of all, that symbol means that current is into the paper, therefore the field will be in a clockwise direction. So those will be the fields. So now let's see how marks can be awarded. So half a mark, full mark for the field lines, and another full mark for the correct direction. Now we shall go to part B. Part B says that a bulb is rated 6 volts, 12 watts. Calculate Roman 1 the current it takes. So current it takes, we know that. So those are 2 marks. We know that power is equal to IV. This P denotes power, I denotes current, and V denotes voltage. We know that power is 12 watts and voltage is 6. So when I substitute, I remain with I as unknown. So when I make I the subject, I'll come up with I being equal to 2 ampere. Basically, that's the current they wanted. Now before we go to Roman 2, let's see how marks can be awarded. So half a mark for the correct formula, half a mark for the correct substitution, and half a mark for the final answer. Now Roman 2 says that calculate the energy it supplies in 30 seconds. So 30 seconds is the time, so we know the time. Therefore we know that we shall say that energy supplied is equal to power times time. Power is 12 watts and time is 30 seconds. So when I multiply the 2, I'll come up with 360 joules as my energy supplied. Therefore half a mark will be for the correct formula, half a mark for substitution, half a mark for final answer. That's how the 1.5 mark could come about. So I believe you have marked yourself and checked your progress. So what I'm going to do, I'm going to leave you with another set of questions, and these questions will be from a topic under magnetism, but the subtopic will be electromagnetic effects, and this topic is best for senior 4 students. So that brings us the end of this lesson. Thank you for watching, and be reminded that the solutions for the assignment left will be available in the next video. So if you have not yet subscribed, please click on the subscribe button below this video such that you will receive updates when the video with the solutions has been uploaded. Otherwise, thank you for watching, and if you know any student who is not yet on this platform, please share the link of this video with them so that they can also join and we all benefit as a family.